everyone. Thank you for coming to ITS Arena. This is the first of the type of ITS Arena that is hosted at the Congress of the ITS Europe Congress. And idea of the ITS Arena is to try to get closer to you what are the best and the latest the solutions from the market, and what are the projects that these solutions has been implemented to get maybe that you can get better impression of where are the latest technologies, what are the latest advancements. And today this ITS Arena is dedicated to products and solutions in urban mobility that are really trying to help and support not only the cities but also the citizens, who are in those cities, with green and sustainable urban mobility solutions. And we are aiming to see how we can contribute with these products to make our better versions of the cities. So it's the cities of tomorrow. So and we will have 3 panelists with us here, and I would like just briefly to introduce them. So our first presenter is Ricardo Herranz, and he is the director in the Nomon company that he will try to present you also how to use the mobile phone data and other services to transfer them into the very valuable information of the travel demand and how citizens or the users of the transport system are moving across the network. Then we will move to presentation to Itir Koshkun, and she is the innovation manager from Swarco, and she will show you how the latest solutions in terms of the traffic management, also for the walkability, to improve the walkability, for example, in the city, also the traffic efficiency can be used. And then we will move to presentation of the Jose Maria Aimami, who is coming from the business development from IMSUN, and he will show you how the traffic simulation models can be used to improve the planning of the city, but also how to use the real-time traffic management services in the city. So I will try now to open the floor and to give the floor to Nomon. Ricardo, please, the floor is yours, and you can give us your presentation to the audience.
Thank you very much for can you hear me? Yeah. Thank you very much, Tamara, for the invitation to join the session and for the introduction. Let's see. Good. So just a quick word on Nomon for those of you who do not know who we are. We're a tech company specialized in the application of big data and artificial intelligence technologies to problems related to transportation planning and transportation management. I think the most differentiating aspect of what Nomon does is that the kind of data we work with, the raw material we work with is always geolocation data coming from different types of personal mobile devices, with particular focus on mobile network data coming from mobile network operators that we blend with other types of data sources, data from mobile apps, from connected cars, from smart cards, from public transport smart cards, to fuse this data and to reconstruct mobility patterns. This is a first family of products that we offer. We could call descriptive analytics products or data products that serve origin destination matrices and other types of travel demand indicators for different types of end users. Then we have a second family of products at Nomon that we could describe as predictive and prescriptive analytics that on top of this mobility information layer try to add artificial intelligence, machine learning, predictive models, not only to describe mobility but also to forecast how mobility will behave in the future under different potential scenarios and support decision making. This is another way of looking at this. We start with these mobility analytics solutions that help us detect trends in mobility, detect special events, anomalies, analyze natural experiments, and then we combine this with other data sources through machine learning models to forecast demand and to optimize supply. Well, this is a snapshot of our solution portfolio, just in case you're interested in the variety of solutions we can offer today. I will focus on the first one in this slide, the one called Mobility Insights, which essentially processes mobile network data and blends it with other data sources to provide, as I said before, origin destination matrices and other mobility indicators. And I'm going to illustrate what we can do with this type of data through what I think is particularly interesting, particularly ambitious project, a project we've been developing through different contracts and different phases for the Spanish Ministry of Transport since 2017, and which aims at monitoring mobility in Spain, passenger mobility in Spain, using mobile network data and other big data sources. The project started, as I say, in 2017 through a first pilot project. The ministry wanted to validate the idea of replacing the traditional national household travel survey by information obtained from mobile network data. So they launched an experimental project at the time that focused on a limited number of days. We analyzed 60 days, 30 days of summer, days of winter, special days, long weekends, etc. We analyzed mobility at NAT3 level in Spain, so province level, and we produced origin-destination matrices segmented by transport mode, trip purpose, social demographic profile of the travelers, etc. It was a very successful project that allowed us to validate the idea that the information traditionally obtained from classical surveys could be replaced or even enriched or enhanced using big data sources. Then the pandemic came in 2020, and the needs of the ministry also changed, right? The first project was very much oriented towards strategic planning, supporting the planning of transport infrastructure, transport services. With the pandemic, the shift focused on short-term mobility behavior, on day-to-day changes. Mobility was changing in a very dynamic way with restrictions, with the evolution of the pandemic. So we got a second contract to monitor on a daily basis mobility in Spain. In this case, we removed the segmentation by transport mode because the priority was to have very, very fast information. So this helped us reduce the processing time and be able to deliver basically in 2 days an OD matrix of the whole country. So basically we were delivering on Thursday what had happened on Tuesday in the country. So this allowed the ministry to track the evolution of mobility behavior throughout the pandemic. And finally, in 2022, once the pandemic was over, the Ministry of Transport decided to merge both approaches into one more ambitious project, which is the one that is coming to an end now and will hopefully be renewed soon. So we've been studying for the past 3 years every single trip in Spain, longer than 500 meters. We analyze mobility on a daily basis. We produce daily matrices with total mobility flows, and then for a subset of days of every month, we analyze in more detail mode segmentation. We analyze the behavior of main transport hubs in Spain, and we also produce a number of what we call route matrices, so basically matrices with the route choices in the national road network. It's difficult to see it in this slide, but there's a number of data products that are open data, are available from the website of the Ministry of Transport. So anyone who's interested can download the data, can play with it, can visualize it. There is also a set of visualization tools to interact with the data and explore it. But some results, some examples of the what you have in these dashboards from the website of the Ministry of Transport. You have mobility, intra-city mobility, inter-province flows, different types of visualizations. And since this is an ITS conference, I decided to highlight this product, which I think is very innovative and very interesting. It's integrated into the Hermes platform, which is a visualization platform, again, developed by the Ministry of Transport. What we do here is analyzing every road stretch in the network. So what you can do here is clicking on any road stretch of the main of the main road network in Spain, and analyzing the local OD matrix associated to that particular road. So how many people are traveling through that stretch, from where they come, where they go, what is the segmentation of these people, social demographic profile, segmentation by vehicle type, different types of segmentations. This has been used for many things. There's many uses of this. There's a variety of uses of this data. This is an anecdotal example, but which is nice. It's a study that was performed by the Ministry of Transport with the mobility during the ski season. So basically, what they observed is that there was a high correlation with the mobility to ski areas during the weekends where there were more snow. This is kind of evident, right? But now we can quantify these type of things, and this illustrates also the fact that these data are not only useful for transportation, but also for other policy domains. In this case, tourism, which is of course very relevant in the Spanish economy. These data are open data, so they have also been extensively used for scientific research. There's more than 40 or 50 papers published based on this data. Again, not only in transportation, but also in other fields such as epidemiology, tourism, etc. And they have been used also by other companies to develop some innovative services. There's a variety of companies in the market now that post-process this data, blend them with all the data, and offer new services to their customers based on the mobility data we produce for the government. So just to finish, I think I may still have 1 or 2 minutes.
Easy.
So just a few lessons learned and some ideas about where we will go from here in the future. Lessons learned. I think there's a lot of benefits in open data, and it's something that we didn't realize at the beginning. When this project was launched a few years ago, basically we said, fuck, right? They are publishing the data, so nobody else will come to us and buy this data anymore. First, this is not true, because you cannot cover all the application. And second, I think this is vastly compensated by the benefits of open data. First, the data is now widely used by the transport sector in Spain. Most transport consultants, most local or regional authorities use this data for transport studies, so when they need more detailed data, they come to us. This is, let's say, a reference or permanently updated and reliable reference on mobility in Spain. So it's kind of the gold standard now for what is the travel demand at country level, and this has somehow multiplied the applications of this data. The fact that it's open data and is used by a vast community of users leads to a natural or spontaneous peer review process, because somebody in the city of Valladolid discovers that a particular OD pair doesn't make sense. So they come to us, and we can refine the algorithms, we can fix bugs, we can improve the quality of the data. We're a small company, we're 50 people at Nomon, so we cannot review in depth every single trip in Spain every day, right? But we have a community of probably hundreds or even thousands of users that are doing this job for us, so that's very interesting. There's multiple applications in other sectors. I already mentioned epidemiology, tourism. There's people using this data also for retail or geomarketing studies. There's been a lot of scientific publications, and as I mentioned before, also innovative solutions and business models developed by third parties that build upon this data. And just to conclude, where do we go from here, or what do we plan to do in the future? First, I think there's an ongoing effort on data standardization and on integrating this data into the so-called integrated mobility data space, or EDIM. This is the acronym in Spanish. There's been a lot of efforts in the past few years on standardizing transportation supply data, less effort on the demand side, so now it's probably the time to also incorporate demand data into this type of integrated mobility data spaces. We're continuously working on improving automatic validation and quality control. It's impossible to validate this data by the human eye or by visual inspection. It's not only the raw data, but also the outputs, I would say, are big data by themselves. You have an OD matrix at municipality or even district level for the whole country with dozens of segmentations, so the output is also big data in a way. So we need to develop automatic checks and automatic quality control mechanisms. Data fusion, of course, we already integrate mobile network data with a number of other data sources, such as transportation supply, land use, population data, but there's new data sources, such as connected car data, that are becoming more and more used now and more available, and they will help us enrich even more the information we extract from mobile network data. There's a lot of room also for improving the way we visualize and the way we exploit this data. And last but not least, and this somehow connects with what I was explaining at the beginning of my presentation, all the work we've done here in this project so far is purely descriptive. What we plan to do in the next project, and I think this is in the mind of the ministry, is to incorporate also some advanced analytical capabilities into the project, predictive modeling for short-term mobility forecasting, clustering techniques for identifying days with similar mobility behavior at different scales, so that later on supply can be adapted to the behavior of demand. There's a number of very interesting possibilities, and if you're interested in the project, you can check. Everything is open, the methodology is open, the data is open, so you can check it on the website of the Ministry of Transport, and also feel free to drop me an email or contact me if you're interested. Thank you very much.
Thank you, Ricardo. Thank you for this interesting insight. So now we will proceed to presentation from Itir. So Itir, you would like maybe to take the floor? So just no problem.
Can you hear me? I'm not sure if you can hear me. All right.
They can hear you very
La
well.
mía es más.
Okay.
Ya es más.
So in my part, I will be talking about adapting roads to changing needs, because as of today, we know that the road users out there are mixed. We don't have a 100% autonomous vehicle. And even in a world where we're looking towards 100% penetration of AVs, we still need infrastructure, and I will try to explain how. I only have a couple slides, so it will not be a long presentation. But just to give you an idea, today I will be talking about adaptive intersection control. So it is not in the most innovative technology as of today. We have this out there since the early 80s. So it is not the most innovative, but it is an evolving project. And I will try to give you the basic logic and then share the two most innovative activities, innovative projects that we did building on adaptive intersection control. So what is an adaptive intersection control? It is a flexible, responsive traffic management system that basically reacts dynamically in real time. So it receives data from intersection, it receives data from the detectors that are placed on an intersection, and that can be inductive loops that are mounted under the road, that can be cameras, that can be GPS, or any sort of detector that is able to provide this data. This is then communicated to the traffic light controller, and based on this incoming data, the system understands how the current situation looks like and how it can look like in the short term. And with that, the initiation of the change of signal phases starts. So we talk about optimization, as I said, optimization of the intersection operation, but we also talk about prioritizing. We say, for example, prioritizing public transport to increase the reliability of public transport services. We can talk about emergency vehicles to give priority to them at the intersection so they can reach their destination faster. And then we also have informing. And in this one, this is mainly looking at empowering the road users. So we are sharing the signal phase information to the road user, plus the speed information, speed advice. So to tell them, if you follow this speed, you will be able to pass the next intersection without stopping. You can see on this map here on the right side, this is the footprint of Swarco, that we have already adaptive intersection control in place. The colors indicate different types of adaptive control logic, but this is, as I mentioned, this is a technology, it's evolving, it's out there since early 80s. I just have a short video, but I guess we need to switch.
Yes, going. Is that it?
Yeah, it's actually playing. Okay.
Playing.
So this is a company, Schlotauer is an engineering company that is owned by Swarco. Now this shows how the vehicle is approaching to an intersection. It reaches this square indicates the inductive loop. It is detected. The change of signal phase is initiated. And now you can see that it moves. Now in the video you will see when we introduce CV2X technologies, how it basically changes the efficiency of the system. Now, when the vehicle approaches, the signal is already sent beforehand, so in advance, and the controller therefore initiates the signal change in advance. Now, of course, this is an overly simplified video, so please don't look at the positioning or anything like that. This is overly simplified, but this is a good example that especially when you implement this in a busy urban intersection, the efficiency of this system is quite evident. Right, so the last two innovative projects that I would like to share is first starting with the smart AI. So as it stays with the name, smart AI basically looks at introducing AI in the control algorithm. So here we have that the system is continuously learning from the patterns such as school zones, events, and so on. And essentially, this AI-based adaptive system can basically predict the congestion. So it doesn't only look what is happening as of today, but it also estimates and predicts what will happen next. How it basically works is that, again, we have detector placed at the intersection. It receives the data on the estimated time of arrival on the objects at the intersection. And the reinforcement learning algorithm in the logic also estimates the ETA of the objects that are outside of our range. So at the end of the day, the goal with this is not to react on the current situation, but to predict how the traffic will be and act accordingly. The next is I find a quite important project that we have. This is basically looking at how to allow visually impaired people to communicate with intersections. So we have implemented this in Finland. This started as a pilot project. Now we have deployed this over 10 intersections. We collaborated for this project with an app provider where the users, this app is already established, so there are quite many users, and the visually impaired user simply puts in the destination, and as he or she starts to walk on the street, it already knows where they will make the turn. And according to that, as that person approaches the intersection, an automatic message is sent to the intersection to make this change automatically, so that they don't need to search for the push button or anything like that. Basically, a more stress-free, fully automatic, and more comfortable journey. And I believe, this is my last slide and last comments, that this is a great example that even though this is the core logic of intersection optimization, this is the way how this solution can be tailored to the specific needs out there. And it is an evolving technology, as I mentioned. That will be all. Thank you.
Thank you.
And here's a short video, but this just explains what I just showed you.
Yeah.
So, yeah.
Now we can do it. Thank you. Thank you very much. Okay, I hope you are getting inspired, because we will ask you later on some questions about how you feel this is challenging to implement, or which solution you see that will be very helpful to you as a citizen. But now I would like to move the floor to next speaker, Jose Maria. Please, the floor is yours, and you can show us what are the latest solutions from the AIMSON.
Thank you, Tamara. I know I talk a lot and tend to extend too much. I promise to keep it short and to have time for discussion. And welcome, everyone. I come from AIMSON, and I'm going to go straight to the point. We're a company based in Barcelona with international presence, and trying to answer for the last almost 30 years a classic question in mobility. What is the what-if question? Okay, what happens if I'm going to do a change? What I have to introduce, add new infrastructure, add new public transport, change, do a modal shift, and understand the impact of that. And of course, given that we are at an ITS conference, especially what if I introduce new technologies, new adaptive signaling, new nowadays connected vehicle. I'm going to go to that to the last. And to do so, we are trying to make the classical steps, trying to understand mobility, understand the performance of your network, then going one step further, going to forecast, trying to forecast my future. It is a bit more tricky. And finally, if I can, and I have the possibility, try to decide, make decisions based on this information. Of course, informed decisions, that's the key element here, providing as much as information, as much as metrics, KPIs, to have an informed decision and not just decide based on guesses. We are well known in the sector for one specific element. We are well known for simulation. We've been delivering solutions based on simulation for a long time. In this process and of transformation of the sector as well on data, we were talking about data earlier on, we were also swallowing a lot of data and processing a lot of data. And nowadays we are not only focused in simulation, our solutions now have a dual approach, combining AI-based data-driven techniques with simulation, trying to provide and to make profit of the both best of both worlds. But what is clear that we try to provide that in a true integrated environment. Okay? We try to provide tools that are meaningful, that are comprehensive, but then at the end, you don't die while using it, but you have a nice environment to interact with. AIMSON also specializes in providing customized solutions. We know that the sector is complex, plenty of protocols, plenty of data exchanges, plenty of different needs, and solutions need to be adapted up to a point. We try to make, as I said, easy access to all our platforms, and trying to uniform them all in something that is easy and that has easy learning curves to get into. And finally, we are trusting in our expertise, again, almost 30 years of experience with a skilled team of people all across the world exchanging experiences between them and with our customers to try to deliver, again, solutions that make sense to people. Going a bit further, it is clear that the mobility can be tackled from different angles, and we can find this in a classic timeline where you typically need to understand what happened in the past, so you need to focus and check data from the past. You need to understand analysis to provide the trends and the situations you had in your networks to learn and to get some insights from it. And then you need to go and, as I said before, predict. And what is prediction? Prediction is a magic word, but that is quite blurry. It's a blurry environment. You can consider prediction for 40 years from now. Classic questions you need to answer, and cities, for example, answers in the sustainable mobility plans. What has to be my city in 20, 30 years from now? Could be something shorter. What happens if there's an event like in Seville, the Cup a few weeks ago? What happens if I'm going to organize a large event in a few months from now? You go into the domain of tactical modeling, the tactical elements, what I need to change that is not fully transforming my city. And finally, you can go to probably the most difficult one, the immediate prediction. What happens in the next hour in my network? What if there are sudden changes, unexpected events, combination of them? I'm having roadworks in my network that makes my network disrupted. So what can I do in these situations? What we're trying to provide here is something that tries to answer everything. We are not saying that we need to answer everything every time, but we have set an adaptable architecture based mostly on simulation, because that's what we know from a long time, but also now very, very well supported and more supported by data-driven solutions, providing offline analytics and real-time analytics that support these simulation environments. We can even get rid of this simulation, and we can provide solutions just based on analytics. And what is also clear, to provide, as I said, a comprehensive environment for this all. Let me explain that with, and we are trying to deliver that as the most standardized way possible, trying to provide a set of comprehensive models that you can, let's say, turn on or turn off depending on your needs. So that's how we try to adapt. Let me go to the focus, and let me explain that with a couple of use cases. As I said, we have examples worldwide, but I wanted to get closer, and we are showing a couple of examples from mainland Europe, to say it somehow. The first one is a very, very interesting, long-lasting project, call it framework that we've been delivering to the city of Paris for the last 15 years. We got a request from the municipality to transform their existing fragmented modeling environment. When we typically apply modeling and simulation to a city, models are usually used for just ad hoc purposes, and they are thrown to the rubbish bin. So there's no continuity in the modeling experiences. They wanted something a bit different. We took this amazing challenge, and we transformed the modeling environment of the city of Paris to just one single file. We are supporting the city of Paris for the last 15 years just using one single modeling file, paris.eng, to simplify it a little bit, that is capable of handling all the transformations of the city for this a decade and a half. And trust me, Paris has experienced thousands of changes, including traffic calming, changes in the bus transport network, plenty of roadworks due to amazing and biggest actually road biggest mobility projects around new transport hubs. There's been an Olympics ongoing, so all these changes and all the evaluation of the schemes were evaluated in a model that was updated and maintained a long time. But it was keeping consistency, keeping as well the local and global impact. The model is global; it's just a model that covers Paris and adapts to the different granularity and aggregations and precision depending on the impact of each scheme. But everything goes back in some kind of layer approach framework that helps in making decisions a bit more informed. The second one I wanted to explain is even closer. It's close to my hometown, Barcelona, and goes to this specific moment in the time frame that I was mentioning before. The short-term real-time prediction. This is our application. This is a commission project. This is an operational project in a freeway for a road operator, Abertis, on a segment of 70 kilometers long freeway in the southern of Barcelona. What we're delivering here, we're delivering a system fully data-driven based, easy to deploy, easy to expand, and easy to scale up to other more complex environments, where we provide a full comprehensive understanding of what's happening in the situation and with the situational awareness, but also this short-term prediction, what happens in the next hour, just using data-driven, but providing full spatial propagation of these predictions. That's quite a novelty in the sector. We are not staying just in providing traffic performance indicators, but also we are providing environmental indicators, we are providing emissions and air quality indicators and prediction, and also risk of accidents. We highlight when there's any risk situation that can tackle to a risk of having an accident. And based on that, we also provide decision support by setting speed recommendations, dynamic speed recommendations that can be fully adaptable and can be adapted to different segmentation, road segmentation. So not only relying on the existing hardware like virtual variable message sign, but also being able to send all this information to quite interesting ITS deployment that goes into the vehicle. At the end, what we are trying to do here is something interesting, and we are now talking a lot about CITS deployments. Of course, hardware is there, but what is important is what type of messages we're going to send. What is the information? What is the intelligence on the messages that we're going to send to the vehicles to actually make a difference on the current way we manage our infrastructures. This is a nice example on how to do it by providing this anticipation, this prediction in the way we manage our networks. After all, we are trying to provide best of both worlds, data-driven approach, simulation approach, trying to deliver this in the best way possible. That's all. Many thanks for your attention. I'm open to questions.
Thank you, Jose Maria. I would like just to, if you can put it on the first slide from the first presentation, because we have some Slido question there. Yes, so you can scan also this QR code, and you will go to the Slido, and you can leave us some comments as well about what you have learned or what you would like to ask our speakers as well. But maybe I would just like to rephrase, because I was really impressed with the level of how, for example, when we started with Ricardo's presentation, we were collecting data by using the interviews. We visit the households to ask the people how you do, how you travel, and we write down by hand. Today we see that we can use with digitalization and new mobile phone data and other, we can improve this communication and really create those surveys in way more efficient and costly a way. Yeah? And then also when we look at the traffic control management, the intersections, and how you don't need to lose the time anymore at the traffic control signal lights. And also like to help the visually impaired people, like to help them to cross the streets. And also the digitalization on the roads. That can be identify what would be congestion ahead so that we can make better trip planning, route choice that we can use, or maybe to prevent some accidents, yeah, and to have notifications more. Today, you know, like when accidents happen, it takes 15, 20 minutes to record with police, to inform some measures, but with automated detections, we can be more proactive. So all of these tools are really using a lot of data, yeah? And you can see they're using a lot of AI technologies, etc. So maybe I would just like to reflect, because I see the questions from the audience are preparing. So I would like to give you the floor, and please introduce yourself, and feel free to ask our presenters.
Hello, thank you. So Gottfried Almer, Asfinag Road Operator in Austria. I find it very interesting. We're trying to do the same things. I have a question to Barcelona system for prediction. How do you, or do you, verify your predictions on the road? So the system has told you something. Who and how is it verified whether this prediction has come true? Thank you very much.
It is true that, I'm sorry? Hello? Okay. It is true that if the predictions cannot be verified, that could be a very useless system. And actually, by default, and as part of the off-the-shelf offering in our predictive environments, both Aimsun Predict and Aimsun Live, these are the commercial names for them, includes a quality manager module. Okay. What we can do, and it's quite easy, is that we have a rolling environment that collects the data and grabs the data from multiple data sources. I forgot to mention that, but we are relying on data fusion from floating car data, from the road sensors, from tolling information that comes, and even from an app from the drivers. We fuse that, and we collect this data to make the predictions. What we can do is, after 1 hour, we can keep collecting the data and compare our predictions based with what happened in the real field. So we keep doing that all the time. Yeah. And then of course, we collect all the metrics on the performance. We typically, in this particular case, we're achieving qualities of 97% on comparison between real data and predictive data. And this leads to, give me a minute because that's an important element. This leads to a split into the two approaches we have. The data-driven approach needs learning and quite a lot of learning. It starts quite damp and gets better a long time, like good wines. Simulation gets an extra bonus in never seen before situations from early the beginning, but gets heavy maintenance. Everything is to try to get the best data, the best quality. We can go from both sides. But overall, what we're trying is to deliver quality systems, for sure.
Okay. Thank you very much. Do we have more questions? If you have more questions from the audience, we will have assistance to you, and we will bring the microphone. If there are more, would you like to ask more? To have a dialogue? Oh, no, okay. Oh, good. Okay, thank you very much. So one of the questions, maybe I can just give the similar question, yeah? And I can maybe either move to you and to ask you, in terms of deployment of the solutions, like if you look at the most challenging part to deploy it in the city, what you would emphasize, and then how you overcome that one, let's say?
Well, it is often the existing infrastructure out there. This is why now, for example, this is an intersection that's been operating. The infrastructure out there is not able to, of course, let's say, doesn't have the capability of this solution, then it means a complete redo, and this is a quite long process, of course. But other than that, if we are talking about adaptive intersection control, there are a lot of studies that shows the value of it already. It's out there, so it's not that we are still discussing that. On that side, I don't see any challenge on this, but yes, still, depending on the country that you talk to, depending on the progress, you still, of course, you are still asked to provide before and after analysis, which is another challenge sometimes, because the traffic situation, you can compare it under the isolated scenarios, right? So we have done several different simulation studies with universities and so on that already have these numbers out there. So I would believe that it's this progress, it's this acceptance towards that we need to change the infrastructure, because there's also another argument that we sometimes hear, which I find it quite dangerous, is that do we even need intersection control? Maybe we will remove all of these intersections and all the signals in the future, which is quite dangerous, because as we have just seen that out there, we have very mixed road users. It's not just about the mixed vehicle types, but it's the mixed road users. And these type of infrastructure is the orchestrator of the needs of balance between public and private need, which is a tough challenge, right? So I believe that that's the main challenge that we need to put out there. Yeah.
Okay, thank you very much. Yeah, I totally agree with that, man. I think maybe also with the incident that we had here in Spain, when traffic control lights didn't work, we could also notice that how much congestion was more on the roads. Yeah, so just removing them, what was the final result of that? So, and then I would give the floor also to Ricardo, to you, because you really work with the big data flows, but not only in terms of the volumes in temporal dimension on a daily basis, but you also work in the large scale horizons as well across the time. So what were the challenges? Are these data that you're using are available to the cities or to the national authorities? What type of the national contact points maybe can help? Are you in a connection with them to use this data for your service and your product?
Yeah. The raw data is not openly available, the original data, because of privacy protection reasons. So there's a number of precautions we need to take when dealing with this data. This is personal data, because even if pseudonymized, you could still potentially re-identify a user, right? By looking at his or her mobility over weeks or over several days. So the first measure is to pseudonymize the data. The second measure is that typically what we do in most countries, and certainly in Europe because of GDPR, is that we do not take the data outside the mobile operators' facilities. We deploy our software there, we process the data in their secure environment, and what we take out of this environment is already fully anonymous, aggregated data in the form of OD matrices with different types of segmentations. Once we have that product, this is made available to the citizens, to anyone who wants to use it through this open data portal by the Ministry of Transport, and in the future, most likely through this integrated mobility data space that is being developed. And there at that point, there's no limitation. Everything is publicly available. This is one of the, I think, of the strengths of this project. And I mentioned in my presentation some of the advantages of this open data approach. Also in terms of methodology, which is the other part, right? Because if you do not have access to the raw data, or you cannot validate, or you want to run a different type of algorithm on the data, this is not that easy, right? So what we've done is opening also the methodology. There's a very detailed reports with the validation experiments and so on, which is available. What is not available in this case is the code itself. This is the approach taken by the Ministry of Transport, and I think it's legitimate because it's a very complex application, and you need to find a trade-off, right, between private interests and intellectual property of the companies and the willing to share this knowledge, right, and transparency or algorithmic transparency. So this was solved by publishing the reports, etc. But there's other initiatives at European level. For example, we are now developing for Eurostat, for the European Statistics Office, an open source code to produce, I would say, simpler statistical products, but presence indicators, migration, other types of statistical outputs based also on mobile network data. And in this case, the code is openly available. It can be downloaded from GitHub. So that's, let's say, the extreme in terms of transparency, right? You have the access to some testing data sets plus the code. I think this is an important decision that public administrations must make when dealing with data, with this type of analytic solution. What is the right level of openness? And it's, I don't think there is a one-size-fits-all solution. You need to look at this on a case-by-case basis.
Okay. I see in terms of the challenges and deployment that they are there, present every day, but it's not, you all have already experience in overcoming this one and really having a dialogue, and solving it and looking at the status quo of the cities and also understanding how you can improve and bring this new technology to them. Because we have to close the session, I just want to give... we have a question, sorry. Apologies for that.
Hello?
Yeah, please go.
From the municipality of Trento in Italy. We are a customer of Svarco from 25 years. And I would like to add something about the topic, challenges related to the infrastructure. From the point of view of a city, okay? And I may say that there are mainly two challenges for a city. One is maintenance. Because, okay, everything is very cool, everything goes faster and so on, but you have to maintain the infrastructure. So from the basic loop to the V2X, okay? And the main point is that if something is broken in an intersection, even one sensor this kind of technology may disrupt the whole intersection. So it's, if there are other cities here, I mean, maintenance have to be top, because then your customers would find that intersection is not working and the major calls you just for one inductive loop. And the other challenge that I may see is that is about the public transport, not tram or buses. Okay, in a small city like ours, we have bus stops that are quite close to the intersections, and even though the algorithm may predict that the bus is going to cross, there is no physical time to make the intersection change from red to green, okay? So I would like to underline that if a city wants to implement this kind of management, should talk to the management of the city lights to also foresee different positions maybe for the bus stops. Because the algorithm cannot change immediately from red to green. So it's not really true that there are no challenges, but there is a challenge from maintenance point of view and also from by design. So if you go to a city that already has this network, maybe you have to change something, and cities should be aware of that.
Yeah, and just to maybe add on that.
Absolutely,
Definitely on the first one, on the maintenance, 100%. And I think what we need to move towards also when we're evaluating the impact of these, it's not just about the travel times, right? Where are the other places that we're saving costs? Then we can maybe better understand and have a wider perspective on the costs on the other side as well. I completely agree. And the second part, integration to urban planning, this is absolutely key, not just for this, but also for the CITS solutions so that they don't just stay as a technology layer, but they need to be implemented with the urban mobility plans, let's say with sustainable urban mobility plans, so that we can actually get the most impact out of it. Absolutely.
Actually, this is very interesting because I think we can put in the traffic simulation models and we can see whether the reallocation of the public transport stops can help this one in optimization. Okay, I see that we can have a very nice dialogue after this session. Okay, I would like to thank you all. I think you can really already see. I had one question just to final KPI. If you think of sustainability and the green mobility, what is your product that is really the KPI, the most important that you can impact? Multimodality, connectivity, efficiency, reducing emissions?
Well, in our case, I think the
only one version.
trip rates and maybe model share, if I can come with two.
Okay, it's fair.
Sorry, the impact of
impact, just one word from the KPI.
We are looking at the efficiency, but it's not just one. It's efficiency, safety, and from there on, we're also looking at environmental impact. They are all interconnected.
And Jose Maria?
It's two, but comes together. Informed decisions.
Okay, thank you very much. With this one, I would like to close the session, and I would like also to thank our speakers for your time and also for sharing insights from the latest technologies on the market. Thank you very much.